All right, hello everybody. We're going to continue talking about applications of trigonometry, right? So how can we use this to actually solve problems? And the last time we spoke, we started introducing this vocabulary of angle of elevation and angle of depression, which is basically two phrases that come up a lot when we're describing certain angles within a problem. Right? Certain angles that come up when we're trying to visualize what's going on within a problem. Okay, and today basically what we're going to do is just continue to work through some more problems. And really the important piece in this type of work is, can you take a description of what's going on and translate that into a picture? And we're just going to practice doing that a little bit more. Okay, so just to recap, an angle of elevation is always the angle between the observer and the horizontal looking upwards. And the angle of depression is the angle between the observer and the horizontal looking downwards. So one thing that you should always remember about these, angles of elevation and depression is that they are always between a horizontal, okay? That's a side-to-side line, not an up and down line. All right, so let's look at some more examples. Now, not all examples include an angle of elevation or depression. So here's an example of a description where we don't have that phrasing. A ladder is 8.5 meters long, or a ladder 8.5 meters long, makes an angle of 72 degrees with the ground. How far up the side of a building will it reach? All right, well, if we try and visualize what's going on here, we've got a ladder that's leaning against a building, and they're both kind of on the ground. So I'm going to draw the ground. Here's the ground, and here's a building. And here's the ladder. Here's my terrible, terrible drawing of a ladder. There we go. And the building is perpendicular to the ground, so it makes a right angle with the ground. So that's basically a picture of what's going on. And what you want to do initially is ignore all the numbers and just be able to get that down, because now what we see is we have this right triangle. Once we get that down, we can go back to the problem and start to look at the numbers again and fill in information in our diagram. Okay, so the ladder is 8.5 meters long. That's the length of the ladder. Well, that's this piece here. This over here is 8.5 meters. Okay, it makes an angle of 72 degrees with the ground. So the angle between the ladder and the ground, that's this angle over here. That's 72 degrees. Okay, the question is, how far up the side of the building will it reach? So how far up the side of the building, that's this distance here, will it reach? We want to know this. Okay, so what you may want to do, some people don't have to, but you may want to just redraw this triangle without all of this extra stuff in there. So here's my 72 degrees, here's my 8.5, and here's my x. Okay, and once you have that, and remember that this is a right triangle as well, now we can start to use trigonometry to figure out what x is. And remember, when we're using trigonometry, the very first thing that you want to do is label all your sides. Okay, so I'm going to start with the hypotenuse, and I'm going to go to my right angle, which is right here, and I'm going to go across from it. This is my hypotenuse. And the angle that I'm going to use to label is my 72 degrees, because that's the one that I know. So if I go across from that, that's my opposite. Well, that's my x. And then the final side is the adjacent. Okay, so I'm going to write out so, ca, TOA, because this will help me decide which trig ratio to use. And in this case, x is my opposite side. So I want a trig ratio that uses opposite. Well, that's either sine or tangent. The cosine isn't going to work here because it only uses adjacent and hypotenuse. And if I think about, well, which one of those two will work, I want my opposite and the one that I know is my hypotenuse. So I'm going to have to use sine because that's the trig ratio that uses opposite and hypotenuse. All right, so let's write down the sine ratio. Sine of theta equals opposite over hypotenuse. And now I'll fill in what I know. So I know my angle is 72 degrees. So that's theta. And I know my opposite. Actually, I don't know my opposite. My opposite is x. So I'll replace the O with an x. My hypotenuse, I do know though. That's 8.5. Okay. Now remember this sine of 72 degrees, that's a number that's stored in the memory of your calculator. So I'm going to take out my calculator now. Here it is. And I'm going to enter in sine of 72 degrees, and I get 0.951, rounded to 3 decimal places. So I will just remember that, 0.951, and I'll replace sine of 72 degrees with 0.951 equals x over 8.5. And again, if you want to, you could put this over 1 so that it looks like all of those proportional reasoning equations that we've done earlier this year. Okay, and now to solve for x on the right, well, what are you doing to it? You're dividing by 8.5. How do you undo that? You multiply both sides by 8.5. So I'll do that on both sides. On the right side, the 8.5s cancel. So x is going to equal 8.5 times 0.951 divided by 1. So I'm going to enter that into my calculator. Just clear this out the way. 8.5 times 0.951 divided by 1. And I get, now rounded to the nearest tenth, that would be, well, the tenths position is 1 decimal place, so this is a 0. If I look to the right of that, that's an 8. So that means the 0 has to round up. So it's going to be 8.1. So x equals 8.1 meters. Okay, and the reason why I'm rounding to 1 decimal place, by the way, even though it doesn't say where to round to, is that I like to be consistent with what's given to me in the problem. So what's given to me in the problem in terms of a side length, the other side length is rounded to 1 decimal place. So that's what I'm going to do too. Okay, all right, so that's that one. Now we already did questions 2 and 3 in the previous video. So let's look at examples 4 and 5. And again, what we're really going to focus on here is how do we translate a description of what's going on into a picture. All right, 2 buildings are 18.5 meters apart. The angle of elevation from the top of one building to the top of the other is 18 degrees. If the taller building is 15 meters tall, how tall is the shorter building? Okay, well, there's a lot going on here. Let's start with the first sentence. 2 buildings are 18.5 meters apart. So we've got 2 buildings that are 18.5 meters apart. And the other thing that I'm told, another detail that's important, is that one's taller than the other. All right, so let's just draw 2 buildings. Firstly, they're on the ground, so that's important. Here's one building, and here's another building. And this distance between them is 18.5 meters. Okay, so that's one thing that we know. We know that they're 18.5 meters apart. We also know that one's taller than the other. Okay, the angle of elevation from the top of one building to the top of the other. Well, angle of elevation means we're looking up. If we're looking up, we must be on the shorter building looking up to the taller one. Because if you're on the taller one and you're looking up, you're not going to see the shorter one. right? You'd have to be looking down to see the shorter one. So imagine that you're standing right up here and you're looking up to this taller building, okay? Well, the angle of elevation is between the line of sight and the horizontal. So we've got to draw in this horizontal. There we go. Oh, and oh, that makes a nice little right triangle. That's convenient. And this angle is 18 degrees. Okay, so that's one thing we know. We also know that the taller building is 15 meters tall. So this over here is 15 meters. Okay, how tall is the shorter building? So what we're really trying to find here is this piece. Well, let's just figure out how we're going to do that. We actually know, I put the 18.5 meters down here, but that's actually the same as this length over here, which is part of this triangle. If I can find this piece, I'm going to call this y. If I can find that chunk, then I can find out what x is, because I know that the two of them together have to add up to 15. So that's going to be my roadmap. I'm going to figure out what y is, and I can do that because I have in this right triangle an angle, 18 degrees, and a side, 18.5. So I can find y, and then I'd be able to find x because I know that x plus y has to equal 15 meters. Okay, so that's going to be my process. All right, so let's do it. Now within this right triangle, the one with 18 degrees in it, now I got to label my sides because I've got to use trigonometry here. So let's do that. Well, here's my right angle. Across from it is my hypotenuse. Okay. My 18 degrees, that's the angle that I'm going to use to label. Across from that is my opposite. So my opposite side is y. And then the 18.5 is my adjacent. Okay, well, I'm trying to find side y. That's my opposite side. Remember, so, ka, toa. Trying to find my opposite side, and I have my adjacent. So I want my opposite, I have my adjacent. The trig ratio that uses opposite and adjacent is tangent. So that's the one that I'm going to choose. Tan theta equals opposite over adjacent. And I'm going to fill in what I know. So I know what theta is. It's 18 degrees. My opposite is, I don't know. I'll call that y. And my adjacent is 18.5. Okay. Now I'm going to figure out what tan 18 is. That's a value stored in my calculator. And that is 0.32, this 4 would round up to a 5, so 0.325. All right, 0.325 equals y over 18.5, and if I wanted to, I could put this over 1. Okay, so to isolate y, while I'm dividing it by 18.5, I'm going to multiply both sides by 18.5. Okay, here, I'll just maybe put a line here because I'm cutting into my diagram. Well, these guys cancel. And on the left, I've got 18.5 times 0.325 divided by 1. So I'll enter that into my calculator to get y. 18.5 times 0.325 divided by 1. And I get 6.01. So 6.01 to the nearest tenth is just 6.0. Okay, so I'm going to write that as 6.0 meters. Okay, well, if this chunk is 6.0, then y, if the two of them have to add up to 15, and one of them is 6, well, 6 plus what equals 15, right? The other chunk has to be 9 because 6 plus 9 has to be 15. Or the other way that you could think about it is it's the difference. between the two. 15 meters minus 6 meters, which is 9 meters, right? And maybe I'll just switch colors. So if this is 6 meters, this has to be 9 meters because 6 plus 9 equals 15. Okay? So that one had lots and lots of steps. But once you can kind of figure out what I like to call a roadmap, which is kind of planning out how you're going to get the solution, then usually the process of getting it is just stuff that we've done before. All right, one last question and then we'll be done. A hot air balloon travels 1.2 kilometers horizontally from its takeoff point. The angle of elevation from the takeoff point to the balloon is 15 degrees. How far did the balloon travel? All right, well, the takeoff point is on the ground. So I'm going to draw the ground. Here's the ground. And let's say that this is the takeoff point. Okay. Well, the hot air balloon is going to be in the air. Right now, I apologize. I'm really bad at drawing hot air balloons. So this is going to look more like a light bulb, I think. Or I don't know, like an artichoke or something. It's pretty bad, but there you have it. Okay. And the horizontal distance. So here's the hot air balloon, right? That's the sort of height of the hot air balloon. And the horizontal distance that it's traveled, this part, is 1.2 kilometers. Okay? The angle of elevation, so if you were standing here looking up to the hot air balloon, this angle is 15 degrees. Okay. How far did the balloon actually travel? How far did it actually travel? Well, that's the distance from the takeoff point to where the balloon is now. So that's actually this part here. I'm going to label that X, and that's what we're looking for. And this now creates this nice little right triangle. Okay. So now we just need to find an unknown side in a right triangle. So how do we do that? Well, we start by labeling our sides. And again, I'm going to use this 15 degrees because that's my known angle to label my sides. So my right angle is over here. My hypotenuse is across from it. Okay, so here my unknown is the hypotenuse. My opposite side is the one that's across from the 15. So that's right here. And my adjacent is the 1.2 kilometers. Okay, so if I'm looking at SOHCAHTOA, and I'm trying to choose a trig ratio here. Well, I want the hypotenuse, and I've got the adjacent. So the trig ratio that uses adjacent and hypotenuse is cosine. So I'm going to write out the cosine ratio. Cosine theta equals adjacent over hypotenuse. And I'll fill in what I know. I know that theta is 15 degrees and my adjacent is 1.2. My hypotenuse is, I don't know, it's X. Okay, so I got to now figure out what cosine of 15 degrees is. So I'll take out my calculator again and I'll clear this and I'll put in the cosine of 15 degrees. And that gives me 0.966. That 5, that third digit there, because this is a 9, that will round up to a 6. So 0.966. All right, I'll remember that. So cosine of 15 is 0.96. Whoops. Hold on. Let's erase that. All right, there we go. All right. 0.966 equals 1.2 over X. Okay, and remember, we could write this as over 1. So here we have a case where the unknown is in the denominator. So remember, there's a couple of ways that you could solve that. I think most of you, what you're doing is you're writing the reciprocal of both fractions and setting the reciprocals equal to each other. And remember, the reciprocals are where you flip both of them. So one thing that you could do is instead of writing 0.966 over 1, you write 1 over 0.966. And then equals, instead of 1.2 over x, you've got x over 1.2. Okay, and then you solve that. So what you would do here is, well, you're dividing x by 1.2, so you'd need to multiply both sides by 1.2 and then cancel. So those cancel. And then x is going to equal 1 divided by 0.966 times 1.2. So I'll put that in my calculator. 1 divided by 0.966 times 1.2, and we get 1.24 kilometers. So I'll write that out. 1.24 kilometers. Okay, so that's how far it's actually traveled. Okay, so that's one option. The other thing that you could do, though, is you could just solve it as is. So it's 0.966 over 1 equals 1.2 over x. Well, now we have to take a step to get x out of the denominator. And what we have to do there is undo the division by x. So to do that, we'd have to multiply both sides by x. So these are going to cancel. And I've got 0.966 times x divided by 1. Well, I don't really have to put in the divided by 1 because that's just anything divided by 1 is itself. So what I'm left with on the left is 0.966x equals 1.2. Okay, now to isolate x, well, what I'm doing to x is I'm multiplying it by 0.966. So to undo that, I need to divide it by 0.966. Okay, and then these cancel. And then again, if you put that into your calculator, 1.2 divided by 0.966, you're going to get exactly the same thing. 1.2 divided by 0.966, we get the same thing. Okay, so whichever strategy you want to use to solve it is fine. All right, so that is the end of today's lesson. I will see you guys in a little